Hello friends, welcome to another session. And if you are following this channel for some time, we talk about quant topics that are relevant for CAT, SNAP, NMAT, IFT, all MBA entrance exams, basically in India. So we take a topic, we do it fundamental, and then follow up by two problem sessions. So for logarithm that we are doing currently, we did the foundational and the first level problem session earlier in the last two videos, and I'll put the link in the description box. You can have a look. Those two are very important because this is going to be a problem session two, or which is a little advanced or little nuanced or little complex kind of a problem, which is typically level two, level three kind of a problem that we will focus on here. But yeah, but to understand this, the earlier understandings of fundamentals specifically and problem session one is very important. So please go through those videos first. And like I always say, if I'm doing 7 or 8 problems in a session, you should at least focus on doing 3x or 20 to 25 problems at home to completely gain the understanding. So in 2 sessions of logarithm, if I do around 15, 16 problems, you should be aiming around 50 problems at home from logarithm so that you completely gain mastery out of the subject. If you are facing any difficulty in my explanation, or if you need any help in understanding what is happening, or certain problems you are stuck, you can reach out to me in the mail ID given in the description box, and able to help you. But yeah, like we said before we start the problem, if you see the problem, if you have a understanding of logarithm, try to solve the problem by yourself, or if you know at least the foundational attributes or have the fundamentals done, you try to solve the problem by yourself by pausing the video for a couple of minutes, see whether where you are heading towards, what you are thinking. If you are able to solve or not able to solve, no problem, come back after 2 minutes and see the solution, and see where you possibly have gone wrong or possibly have gone right. So that is one approach I would suggest, rather than continuously watching the video. This is one thing you can do, so that you can also get to practice along with me. Okay, so to start off with this problem, you can see that what is given. So it's given that there is an expression 4 minus log n base 2 and 3 minus log n base 4 less than 0. So there is one possibility when is your numerator greater than 0 and denominator less than 0. Or there is one scenario, numerator less than 0 and denominator greater than 0. So these are the only two possibilities, right? When this whole expression is less than 0, right? So first understand when numerator and denominator will be 0. So I know 4 minus log of n base 2 equal to 0. So that means log of n base 2 is 4. N is 2 to the power 4 or 16. So if I know n is more than 16, 4 minus, if n is more than 16, so if n is more than 16, then I can say log of n base 2 will be more than 4. So in that case, 4 minus log of n base 2 will be less than 0, right? Now in the other case, if I say 3 minus log of n base 4 equal to 0, when log of n base 4 is 3, or n is 4 cube or 64. So if n is less than 64, if n is less than 64, then log of n base 4 will be less than 3, or 3 minus log of n base 4 will be greater than 0, right? So in this case, we see my numerator is greater than 0 and my numerator is less than 0 and my denominator is greater than 0. So 16 to 64, 16 to 64, this is one scenario when this will be less than 0 because your numerator less than 0 and denominator more than 0. Similarly, there is another scenario when n is less than 16 and n is greater than 64. So this is also a scenario when your numerator is greater than 0 and your denominator less than 0. So this is also a scenario when you get the overall value as less than 0. But this we can't focus because this is a infinite. This will give you infinite solution. This one will give you infinite solution. So I have to focus on this one. So this is my right answer. So I know 16 less than n less than 64 will be my solution, because this other one, this one typically, this one will give you n less than 16. Obviously, there is a finite solution because n cannot be more than less than 0 individually, because it's at log, and I know log of a negative number is not right, not possible. Now, n greater than 64 has infinite values, so their way we cannot narrow down from here. The other way is 16 to 64. It's a closed interval, and 16 to 64, we can think of how many values. If 16 and 64 are not included, uh, then we have 64 minus 16, which is 48, and then you have 48 minus 1 or 47 values. So 47 distinct integers, those are needed. 16 and 64 are not included. Then 64 minus 16 minus 1 is basically number of distinct integer that will satisfy this condition. That is 47 total integers. Okay. Hope this is clear to how we approach this kind of a problem. But your fundamental should be clear. You know, numerator more than 0, denominator less than 0, denominator more than 0, numerator less than 0. In only these two cases, you can get the outcome as a negative number. And then you satisfy the condition on where numerator will be less than 0, but denominator more than 0, or where numerator more than 0, denominator less than 0. Let's go to the next problem. So it says if log of a base 15 plus log of a base 32 equal to log of index a. Okay, then a must lie in the range. So basically you have to find out the range of a. Okay, so from log of a base 15 plus log of a base 32, I can divide this into, okay, log of a base 32, this divided by log of a base 15 into log of a base 32. Similarly, this can be written as log of a base 15 into log of a base 32. So basically, since you have a plus b by ab, I'm writing this as a by ab plus b by ab, right? So here this will get cancelled, here this will get cancelled. So I can write this as 1 by log of a base 32 plus 1 by log of a base 15. So from here, I can easily write this as log of 32 base a plus log of 15 base a, right? So this is possible. Now this is equal to 4. Now, so if I say log of a base 32 plus log of 15 base a, sorry, 32 base a and 15 base a is equal to 4. Now from here I can say log of a 32 into 15 is equal to 4, or we can say a to the power 4 is equal to 32 into 15, right? A to the power 4 is basically 32 into 15, right? So what is 32 into 15? A to the power 4. 480. A to the power 4 is 480. Now, if I see, if a has to be an integer, if a has to be an integer, a must lie between what? So I know 4 to the power 4 is 256. and 5 to the power 4 is 625. So can I say A lies between 4 and 5? This is your answer. So A lies between 4 and 5, and obviously A is not an integer, but A lies between 4 and 5. You will get 3, 4 options typically, and this will be one of the options. So A to the power 4 is 480. Then you from there you can calculate A, and then based on the options you can choose where A will fall. At a high level, A will lie between 4 and 5, because 4 to the power 4 and 5 to the power 4 is where the range between which 480 lies. Okay. Let's move to the next one. It says log of 12 base 27. Whenever you have log like this 27, 16, something like this, try to see if you can further simplify them, because that will be helpful, right? So, okay. So from here, find log of 108 base 8. Okay, first simplify what is log of 108 base 8. So can I write log of 108 base 8 is equal to log of 27 into 4 base 8. Okay, so log of AB is nothing but log of 27 base 8 plus log of 4 base 8. So here I can say this is log of 2 cube and log of 3 cube plus log of 2 cube 2 square. So can I say 3 by 3 coming in front and log of 3 base 2 plus 2 by 3 coming in front. This is log of 2 base 2, right? So from here we can say log of 3 base 2 plus 2 by 3, because 3 get cancelled here and log of 2 base 2 is 1. So this is what 2 by 3 log of 3 base 2. So what I need to find out is this value from what is given. If I can find out this value from what is given, it should be very simple for me. Now let's see if I can figure out this log of 3 base 2, right? Now log of 3 base 2, if you see this carefully, it's basically as log of 27. Yeah. Okay. So log of 27 by 12 is equal to A. That is. Now, if you see this carefully, here we have 27, which is 3 cube, and 12 is not something's cube. But if you see the other one, log of 16 base 9 is equal to B. Now you see the 16 is 2 to the power 4 and 9 is 3 squared. So from here it makes sense. Somehow you think 2 and 3 are in the base, 2 is in the value and 3 is in the base. So 2 and 3 we can get easily from the B. So let's first focus on B and see from B if I can get log of 3 base 2. So if I further break down B, it will become log of 3 square and 2 to the power 4 equal to B. So it will be 4 in front and 2 in front, and log of 2 base 3 is equal to B, or 2 get cancelled. So I can say log of 2 base 3 is equal to B by 2. So from here I can say log of 3 base 2, sorry, 3 base 2 is equal to nothing but 2 by B. So that's what we got. So we don't need this at all. This part we don't need. So I know log of 3 base 2 is 2 by B. So from here I can easily calculate it is 2 by B plus 2 by 3. So this is my answer. 2 by B plus 2 by 3. You can further simplify given on what is given in the question, but you know log of 3 base 2, you can easily calculate. So understand what is, so whenever there is a higher value of log, try to see what is asked, what has been asked, see how you can simplify the ask, and then see what you need to find out from the given one. So rather than, because if you try to do log of 27 base 12 from A and you will get something, you don't know what you need. to get the answer. So first start from the answer, break it down into simpler values and see what is actually needed at the code level, because sometimes they put it in the higher power of 3, higher power of 2. So break down what has been asked into simpler values, like we did it into log 3 base 2 and plus 2 by 3. So then we narrow down, we need log 3 base 2. We actually attacked B and break it down and get out the value of log 3 base 2 from there. If we have started the other way, by calculating what is A, and from there we try to break down, from B we try to break down. This is a mindless search without knowing what you need. So first understand what you need, then go back to the problem and see which one will give you fast, and that will be the fastest way to solve this kind of problem. Hope this is clear. If not, please drop a comment in the description box, and in the comment section I will be able to respond. Okay. Now let's see the next problem. What it says, log of 4 base 2. Okay. So log of 4 base 2 into log of 8 base 4. So you can see a pattern, log of 16 base 8, so on. The final value is 49. Okay. So what is log of 4 base 2? Let me write. So log 4 by log 2 into log 8 by log 4. So sorry, this is log 2 into log 16 by log 8. So you don't have to do anything. You can see this all are getting cancelled, right? These all are typically getting cancelled. So log 16, then the next one will be the log 32 base 16. So log 32 by log 16. So this will get cancelled. So similarly, what they have asked for is now 49. So the answer is 49. So this is one way you can do it. The other way of doing it, you can, from there you can continue and get the value of 49, but I will give you a better way rather than doing it this way. So let's focus on a faster approach. This will also give you the answer, but I'll focus on the faster one. So what is log of 4 base 2? 4 base 2 is nothing but log of 2 base 2 square, or I can say 2 log of 2 base 2, or the answer is 2, right? So log of 2, 4 base 2 is 2. Okay. And now what is log of 8 base 4? Again, log of 2 square into 2 cube, or we can say 3 by 2, log of 2 base 2, or answer is 3 by 2. Similarly, what is log of 16 base 8? So again, log of 2 cube, 2 to the power 4. So from here we can say 4 by 3, log of 2 base 2, and the answer is 4 by 3. So what you see from here, it is given first is 2, then it is 3 by 2, then it is 4 by 3, then it will be 5 by 4, something like that it will go on. So 2, 2 get cancelled here, 3, 3 get cancelled here, 4, 4 get cancelled here. So you possibly will get 49 when it is 49 by 48. The previous one will be 48 by 47. This will get cancelled, this will get cancelled. So your answer should be this term. At which term you get this? So you get, so if you understand correctly, in the second term, I get 3 on the numerator. In the third term, I get 4 in numerator. In the first term, I get 2 in the numerator. So you will get 49 in the numerator when the term is 49 plus 1, or 50. When it's the 50th term, n is 50th, that's when you get, sorry, n is 48th. Sorry, my bad. N is 48, because in the first term you get 2 in the numerator, in the second term you get 3 in the numerator, in the third term means this, in the third term you get 4 in the numerator, right? So in the third term you get 4 in numerator, second term you get 3 in numerator. So in 48th term you will get 49 in numerator. So that's where you should stop, and n value should be 48. Okay, this is clear. Let's move on. Next problem. Okay. Now, first understand what is 0.0625. If you understand this, so this is nothing but, if you do a simplification, it is 625 divided by 1,000. Or we can say this is, if you divide by 25, it will be 25 square, 25 and then 400. And if I divide 5, it will be 5 by 80, or I'll say 1 by 16. So this is 1 by 16, right? First divided by 25, then by 5, then by 5 again. So 1 by 16. Okay. So this is nothing but 4 to the power minus 2. 4 to the power minus 2. So what is given, I can write this as 4 to the power 6 plus 12 plus 18 plus dot 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 plus 6x is equal to 4 to the power minus 2 to the power minus 84, right? So here I can say 4 to the power 6. If I take common, things are becoming 1 plus 2 plus 3, not x, is equal to 4 to the power minus 168, right? 4 to the power minus 168. Oh, minus 84. So it is not 168. So it will be plus 168. 4 to the power minus 2 to the power minus 84. So it will become 4 to the power 168, right? Now, basic of indices, that's where you should go through the indices. And if you are not clear on the indices, algebra playlist is given. You go through that. We have covered indices in very detail, how to calculate indices, and those fundamentals should be clear. That's why we covered it earlier before doing algebra. So here 4 to the power 6, now we know from a AP formula, and I will do it in the next section, is AP is 1 plus 2 plus 3 dot, 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 till n term. As of now, you just remember this, n into n plus 1 by 2. This is the formula. So till x here, so that means it will be x into x plus 1 by 2 is equal to 4 to the power 168. So from here, we can say clearly that 6 into x plus 1 into x by 2 is equal to 168, right? You know this, so this is 3. 3 get cancelled, this is 56. So I can say x into x plus 1 is 56. So that typically gives me x as 7. So x as 7. So the value of x is 7, right? So hope this is clear. So what we did, we first break down 0.0625 into a power of 4, and then so that it becomes equivalent to the left hand side, and we can easily equate the exponents, and that's what we did when the bases are same. 4 to the power 168 in the right, and then 4 to the power 6 in bracket 1 plus 1 to x in the left, then bases are same. So we just consider when the bases are same, the exponent should be equal, and that's where we applied the application and we got the value of x. Okay, now you may think from x into x plus 1 how we got 56. So I'll quickly show you. So x into x plus 1 is 56. So you know x has to be a integer. So then I know you can do this, x squared plus x minus 56 equal to 0. And then from there you can say x squared plus 8x minus 7x minus 56 equal to 0. You can solve this, and from there you can see x will get plus 7 or minus 8. Now x cannot be minus 8. So then x will be 7. Now n is 1624 square. Okay. Now what is given? If I 1 by log n base 2, can I write it as log of 2 base n? Similarly, 1 by log n base 3, I will be able to write it as log 3 base n. So my entire expression becomes log of 2 base n plus log of 3 base n plus log of 4 base n till log of 1624 base n. What I did by taking the reciprocals is making sure the bases are all same, which was not given in the problem. We just tweaked a bit and then made all the bases are same. So when all the bases are same, then I know log of n, this is 2 into 3 into 4 into 10624. So can I say this is nothing but 1624 factorial? This is nothing but 1624 factorial. So if I say 4 factorial means what? 4 into 3 into 2 into 1. So 1624 factorial means 1624 till 1. Now you can easily add, multiply 1 in this. It will not change. So 1 is not here, but 1 multiplication will not change. So I can consider this. There is a, we can easily consider that there is a 1 as well. So then this entire page becomes 1624 factorial. So n, if I replace now, n is 1624 factorial whole square, and my this is 1624 factorial. So from here I can say half is out, or 2 is the power of the base, and log of 1624 factorial, and in the base also you have 1624 factorial. So this will be 1 and the answer is half. Okay, so this part will be 1 and the answer will be half. Right? So it looks complex, but the problem is very simple. You just need to know how to do it. So basically, when you see your, if you have given 1 by something, or even if it's not given 1 by something, if you see all the bases are not same, but all the actual values are kind of same, then you do a reciprocal so that values become in the base and the base becomes the value. So basically then it's easy for you to go ahead, because when bases are same, you can do a lot of application, a lot of operations in logarithm. That's what comes with more and more practice. The more you do practice, the more you get confident at it. The next problem, see what it says. So last problem for today, log of 9, the log of 2, 1 plus log of 3, 1 plus 2 log x base 2, and then there are 2, that is equal to half. So this is given to you. So we'll go one by one. So first this 9 will go on the right. So we can say 3 log 2 base 1 plus log 3 at base 1 plus log of 2 base x square. So I'll just put the 2 on the top of the square. So this is nothing but 9 to the power half, or 3 we can say, because 9 goes to the right and it will become 9 to the power half. Okay, so this 3 will get cancelled. So this, now we'll have 1 on the right. So I can write 1 plus log of 3, 1 plus log of x square base 2 square base 2 is equal to 2 to the power 1. This 2 will go on the right, and right now have 1. So 2 to the power 1. So now this 1 will go on the other side. So log of 3, 1 plus log of x square base 2. This is 2 minus 1 equal to 1. So this 1 will come on the right, and this is how it is. So then this 3 will go to the right. So 1 plus log of x square base 2 is equal to 3 to the power 1 or 3. Okay, so 3 to the power 1 or 3. So can I say log of x square base 2 is nothing but 2. So basically this 1 will go right, and 3 minus 1 will be equal to 2. So then from here we can say x square is equal to 2 square, or x is equal to 2. X will not be equal to minus 2. x will not be equal to -2 because log cannot have a negative value. So x will be equal to 2. Okay, so I hope this is clear and you completely understood the problems. So thanks for your time. If you have any doubt, please drop a comment or you can mail me and we can take it from there. So please like, share, subscribe because a lot of time goes into creating such videos and shortlist the problems and make it easily consumable for you. But please do that, so that will be a motivation for me. On the other front, please apply. So together, logarithm session 1, session 2, we have covered around 15, 16 problems. So at least try 50 problems at home. If you are stuck somewhere, drop a note in the comment section, or if you want a focus session from me, drop an email and we can take it there. But the idea is you do that 45, 50 problems at home and you will be able to master logarithm completely. And logarithm is one topic you see invariably every year CAT has problem from here. And in certain cases it's more than one, and most of the cases it is around 2 or higher. So log is a very important topic in your algebra. So please master it and reach out if you need any help. See you next time. Thank you. Bye.